Welcome to lesson 12.4. Today we're going to look at a great shortcut called a derivative. I'm super excited to teach it to you, but before we do that, let's review what we learned on lesson 12.3, specifically with limits of values as they approach either a point, like they're instantaneous. The velocity or rate of change is what we heard a lot about last class. And so we came up with this formula saying, hey, we can find the limit or the tangent line, the slope of the tangent line, by using a limit. And so they call this y here. I'm going to change this to an f of x just momentarily. By using the formula that the limit as h approaches 0 of f of x minus h, or plus h rather, minus f of x divided by h, that this limit could give us the slope of the tangent line at any one point. And so what we learned to do last class is we would substitute in our values here. And so and this would be the slope. Let me say m equals. And so here I would have the limit as h approaches 0. I'm going to plug in x plus h everywhere I see the x in this equation. I'm going to substitute. Whoops, my bad there. That would be 10 times x plus h minus 3 times x plus h quantity squared. And then I subtract here. And inside these brackets, I'll put 10x minus 3x squared. I'll close those brackets. The reason I did that is to help me remember to distribute this negative through. And so what will happen is very frequently we will see that the limits will quickly begin to simplify. And so when I distribute here and here, I'm going to have 10x plus 10h minus, here I need to do a FOIL. So I'll do it up here, x plus h plus x plus h. We saw this a few times, last class. And technically I would need to multiply this by 3, which you can do at the start or at the end, but since we did this FOIL so many times last class, we saw that would be x squared plus xh and another hx. So we'd have 2 hx's plus h squared. I'm going to rewrite it that way. So I'll say this is 3 times the x squared plus 2 hx's plus h squared, which would simplify when I distribute that through to be 3. Oops. Let me take away the parentheses. So I'm multiplying it through. Well, there I did it again. 3x squared plus 3 times 2 is 6 hx. And then 3 times h squared is 3h squared. So I'm going to substitute that in. Right here, I'm subtracting all of that. So I'll subtract 3x squared plus 6hx. Forgot the h there. hx plus 3h squared. Finally, I'm going to distribute this portion through. I'll have a minus 10x plus a 3x squared. And all of this would be divided by h. And so I go to simplify. I see I have a positive 10x here and a negative 10x. Those simplify with one another. It looks like let's see here, a minus 3x squared and a positive 3x squared here. So I'll rewrite this, and while I rewrite it, I will factor out everything that has, I think everything has shared h value. So I'll factor out the h, and I'll say, what does that leave me with? Well, it leaves me with 10 here. I need to distribute, so it'll be a negative 6h. So the negative goes here and there. So negative 6hx, when I factor out that, will become just a negative 6x. And then here, when I factor out, it'll be a negative 3h. Only one h left over. The second h comes out over here, all divided by h. This stage, I can see that these h's simplify, and I could do a direct substitution. And so now this limit, or the slope, would equal 10 minus 6x minus 3 times 0. 3 times 0 disappears. And so we have 10 minus 6x. Now that's the slope at any point, but we specifically want the point when x is 2. That's an x. And so what's the slope when x equals 2? Is we'd have 10 minus 6 times 2. That's 10 minus 12 is equal to negative 2. And so we get A here as a solution. Now, after doing all of this problem, let's check it out in the calculator. F of x equals 10x minus 3x squared, 10x minus 3x squared. There's the graph. And on this problem in particular, we want to know the point 2, 8. And so I'm going to use that as h is 2, k as 8. And we're saying the slope of the line at any point would be 10 equals, or excuse me, m equals 10 minus 6, and it would be any x value we're looking for. I'm going to use h here momentarily, and if I wanted to graph this, I could say y minus that k value would equal, and usually we put this in parentheses. I'm using point slope here as we learned last class, would equal m times x minus h. Okay, and so as you can see here, when the slope is at the point 2, 8, we have a slope. Here's that point. I don't know why they're not showing me a dot, because they are perfectly touching one another right there at that point. You can see that the slope is negative 2 going through that point. But if we wanted to find other places on this graph, what we did last time is we just adjusted some of the points. If I said, okay, I want to know about it 0, 0, put 0, 0 here, and 0, 0 at the origin, you would see that the slope of this tangent line happens to be 10, and it would go right through that point. And you could adjust all the way around these points to find your values. So it's, as long as whatever you use for h, and the easier way even doing this would be, say, k equals f of h, just like this. Now, as and I'm going to change one thing on this. I'm going to make h count by ones here. Do negative 5 and 5. Maybe that'll help me. Well, for some reason it's not really letting me. There it goes. Get a slider back. And what you can see here is, as I go through this graph, what's going to happen, let me zoom out, is every time I change h value, you can see that it's creating a tangent line going through the parabola there, and it's showing you your slope here. There's the slope when the tangent line, which is a line that just touches that graph at one point. All right, with all that extra being done, let's look at number 2 here. It says find the equation for the slope of the graph y equals x cubed plus 3x at any point. So again, the way we did this is I treated that as f of x, so I could use the same formula. And so the slope m will equal the limit as h approaches 0 of f of x plus h minus f of x. And, you know, one thing we could have done last time is probably plugged in the 2 from the get-go. You know, might have simplified our problem, but it is what it is. And so let's continue on solving this one. All right, so the limit here as h approaches 0 of f of x plus h means we're going to have x plus h quantity cubed plus 3 times x plus h minus, and it'll be minus this whole equation. You need to set those in those brackets to make sure we distribute. And so it'll be minus x cubed plus 3x. All this will be divided by h. So I need to simplify that parenthesis there. It'll be x plus h cubed, which is x plus h times x plus h times another x plus h. And so when I multiply these out, I will first FOIL the front end. We've done that on the previous problem. We had x squared plus 2hx plus h squared. And I now need to multiply that times x plus h for the third time. So I will multiply that through here, do a little another FOIL or another distribution. So x times x is x cubed. That's this one right there. And then x squared I think it said x times x. X squared times x is x cubed, and then x squared times h is h. X squared. Here I'll have 2hx squared, and then 2h squared x, and then here another h squared x, and then finally h cubed. And so when I simplify that, I would have x cubed plus 3, I'm sorry, not 1, 3 hx squareds, and then I have 3 h squared x's right there and there, and then 1 h cubed. All right, with all that, let's go write that in. So we simplified the front end here, and I have x cubed plus 3hx squared plus 3h squared x. You having fun yet? Plus h cubed. And then I will distribute this here. 3x plus 3h, 3x plus 3h. And I will distribute the negative. Minus x cubed minus 3x. Let's see what simplifies here. I can see that I have a 3x, positive 3x, and a negative 3x. Let's simplify. I have an x cubed and a negative x cubed. Those simplify. And, oh wait, I forgot to put all this over h. Okay, and now I see that each term left over shares an h, so I could do a GCF here. And we're about to have our solution. So when I factor out this h, it's left with 3x squared plus 3hx plus h squared. Oh, and plus 3. I missed that. Plus 3. There we go. And so when I go to simplify, what's going to happen is this h and this h will simplify with one another. I forgot the 0 there. And so the limit as h approaches 0, finally we're going to get somewhere. I didn't close that parenthesis there. Is we will have, I can use direct substitution. I don't even have to write the limit. Now that I can directly substitute, I can say this will be 3x squared plus 3 times 0 times x plus 0 squared plus 3. And as we know from our math, multiplying by 0 is 0, so those disappear. And it seems to me the slope would be 3x squared plus 3. 3x squared plus 3, which is answer choice C. We can check this out graphically again. And so this time I'm going to just say f of x equals x cubed plus 3x. And again, I'm going to use the same location, but this time, or same type of equation, except this time I'm going to say for m that it's 3x squared plus 3, 3x squared plus 3. And here I'm going to take off, now that I know m, I don't want to actually be looking at m for any one value. What I could do is define the derivative at any one point, or the limit, I'm sorry, at any one point. So right now I'm finding it at 2. If you plug in 2, the y value is 14, as you can see here. The derivative that would just touch that point, just perfectly touch that point right there, would actually come from this equation, which I know that looks like a line, but it's actually, when you multiply that through, it's going to be a cubic graph itself. But that would be the slope, or the equation of the slope of the graph would be 3x squared plus 3. And you can see that that is a tangent line there. And if I moved h around, let's go to like 0. Moved h to 0, you'll see there's also a tangent there. It's only touching that graph in one place and only one place. Nowhere else along the graph is it touching. So no matter what value you put in here, you would have a graph that's only touching that one spot and not going through multiple times. Now that was a hard way of doing it. Let's learn about some shortcuts, what's called a derivative. So we are going to find instantaneous rates of change by calculating derivatives. It's a lot easier than using the limits. So a derivative is just what I've been talking about. The derivative is going to find the instantaneous slope or rate of change or velocity in any equation. Now, how do we find a derivative? How it's found is this. Let's just say you had an equation or a function f of x equals x to the power of n. The derivative, and here's the symbol for it. Right here, this is the symbol for a derivative, is going to be found by multiplying the function derivative. There we go. Multiplying that function by whatever the power was, and then subtracting the power by 1. Okay, and that's what we call a derivative. Notice that's what exactly my equation was here. I took my power, I multiplied this function by it, 3, and I dropped it by power by 1, so it became 3x squared. Over here, this is like the power of 1, so I multiply by 1, so it's 3 times 1, just 3, times x to the power of 0. X to the power of 0 disappears because that's just 1. And so that is what we call a derivative. Okay, and so that's one rule here. We have a couple more rules. The constant of the derivative of a constant is 0. So derivative, if this is f of x equals constant, then its derivative is 0. We have a constant out front, and you have a power. You would multiply those two values, as shown here. And if you have multiple functions, you just keep doing that are adding or subtracting. You just apply the same rule all the way across each time. Okay, so let's try some of these. Instead of going through the whole limit, we're going to do the same thing. We're going to find the derivative of this function, and then we're going to find its slope given those values. So first, let's find the derivative. So you would represent that by saying f prime of x. And what we're going to do is we're going to take the power each time and multiply the front with it. So power is 3, so 3 times 2 is 6. And this becomes 6x to the power of 3 minus 1, which is 2. You just subtract the power. Now I'll do the same on the second portion. I'll take this power 2 and I'll multiply it right there. So 2 times 2 is 4. And my power drops by 1. So 2 minus 1 is 1. So it's the power of the first. Over here, this is like power of 1. So you would take the power of 1 and multiply. So it'd be -7. But this becomes x to the 0. And you don't need to write that. You can just leave it like that. This is a constant. This is what we call a constant. And so its derivative is 0. It disappears. So that right there is my derivative. That equation will find the slope at any one point on this graph. So we want to evaluate the derivative at 1. And we're going to evaluate it at 4. So evaluating it at 1, you'd have 6 times 1 squared plus 4 times 1 minus 7. 1 squared is 1, so 6 times 1 is 6, plus 4, that's 10, minus 7 is 3. So f prime, that's what you can call that, f prime, or the derivative of f at 1 equals 3. And if I want to find f prime, or the derivative of f at 4, f prime of 4, or derivative of f at 4, what I would do is I would plug in this equation with 4. So it'd be 6 times 4 squared plus 4 times 4 minus 7. When I do my math here, I'm going to have 16. 4 times 4 is 16. I got to do PEMDAS. The exponent goes first. Now I multiply this out. 6 times 16 is 96. I need to rewrite this out here. 96 plus another 16 minus 7. So that's going to be 105. F prime of 4, or the derivative of f at 4 equals, oops, not -7, 105. Now, I'll give you one to try. And again, you could check all the stuff I was doing with the calculator earlier. Pause the video if you need more time. So here on example 2, we're going to do the same thing, but just slow it down a little bit so you can see it. So it says find the derivative of the function f of x equals x to the fifth. And so the power rule, what is stating up here, the power rule is simply that if you're looking for the derivative, you take your power and it becomes the constant or multiplies times the constant in the front, I should say. So this would be 5x, and then the power, you just subtract by 1. So 5 minus 1 is 4. And that would be the derivative of this function, which would find our instantaneous velocity or rate of change and such like that we were finding last lesson. Okay, so part B here, it says g of x equals fourth root of x to the sixth. So a very important conversion you need to know is that if g of x is the fourth root of x to the power of 6, that means g of x could also be written as x to the power of 6 divided by 4. You could rewrite it that way, which in turn we could simplify. 6 and 4, they both could be reduced. The value of 2 goes into both of the numerator and denominator there. You could rewrite that as 3 halves. You reduce that. Okay, so what would g prime be? G prime, you would take your 3 halves and move it to the front. 3 halves goes up front. And honestly, I shouldn't be writing that up there because it looks like I'm changing the equation g, and I'm not actually changing g here. So it would be 3 halves x, and then you would subtract this by 1. So 3 halves minus 1 is like subtracting 2 halves, which gives us 1 half. And that you could also rewrite, so 1 divided by 2, that's a square root. You could write this as 3 halves square root of x. That 1/2 power is only on the x, it's not on the 3 halves. That's why they had the 3 halves outside the square root. So you could write it that way. Here's part C. It says h of x is equal to 1 over x to the 10th power. So again, another rule on powers for you to know is that if you have a variable with the power in the denominator, that's the same thing as just having a negative power. You could rewrite this as 1x to the negative 10th power. And so since it's 1x, you don't need the 1 there anymore, that coefficient, it's gone. So what does that mean for my problem? Is I could say h prime, the derivative of h, is going to be take that negative 10, move it to become the constant, and then I subtract 1. Now be careful. Negative 10 minus 1 is not negative 9. Negative 10 minus 1 more, if you think of a number line, if here's 0 and you go all the way over and say that's negative 10 there, if you subtract 1 more, you actually go to negative 11. So this would be to the negative 11th power, which you could rewrite this as negative 10 in the numerator divided by x to the 11th power. You could write it in this form there. And that would be our derivative. So with that, I'm going to allow you to work on this problem. I've put together a few pieces. So just think about this as being x to the first power, the third root of x to the first power here in the denominator. Remember, this means a dividing power of 3. That's like dividing the power by 3. Pause the video if you need more time. Okay, so now that we went over a couple more simpler examples, let's come back and start putting some of these rules together. So if I wanted to find the derivative of f of x here, what I would say is f prime, the derivative of f would be equal to the power 2 comes up and multiplies with the 6, so it'd be 12x to the first power. You don't need the 1 there anymore. And then the derivative of the constant disappears. So this derivative would simply be 12x. On part B here, I have this equation g of x, but I'm going to simplify this. The first thing I'm going to do is distribute here. So I'm going to say this is 2x cubed times 5x, so that's going to be 10x to the 4th power. There's 3 powers, there's another power. So when I multiply, you add them up. And then 2x cubed times a negative 3 is going to be a negative 6x to the 3rd power. That's our g of x equation. So if I wanted to find g prime, take the power of 4, multiply it with the 10. So I get 40x, subtract a power to the 3rd, minus 3 multiplies with a 6 and becomes 18. Again, subtract a power, so 3 becomes a power of 2. That's my derivative here with respect to x. And here's part C. On this one, notice that we're working with the division. We could use some algebra rules, though, to simplify the function h. We can notice that in the numerator, each term has a value of x, so I could do a greatest common factor and divide out that power of x that there is shared all the way across. And so I'm left with 3x squared minus 2x plus 1, because x divided by x is 1. All this divided by x. When I simplify, those disappear, which means I could have written h of x as being equal to 3x squared minus 2x plus 1. So what does that mean for my derivative? That means the derivative of h, here you would take your 2, multiply, and you would have 6x, subtract a power, that'd be to the first. Here, this is the power of 1, so it'd be negative 2. The x would disappear because it'd be x to the 0 power. Constant goes away. Here is my derivative. And here's one for you to try. Pause the video if you need more time. Example 4, particles. The distance a particle moves along a path is defined by the equation s of t equals 6t minus 2t cubed plus 4, where t is given in seconds and the distance of a particle is given in millimeters. Find the expression for the instantaneous velocity of this particle. So the instantaneous velocity is going to simply be the derivative. V of t is going to equal the derivative of s. Okay, so that's the relationship here. A derivative is the instantaneous velocity. So the first function tells you like the position, the derivative. So the original function gives you the position of the graph at any time. The derivative, what that's going to find is its instantaneous velocity. So we're going to start with s of t here is 6t minus 2t cubed plus 4. And this time I'm going to take derivative with respect to t here. So v of t will equal the derivative. So 6t has a power of 1. This just becomes 6. The t to the 0, you don't need to write. It disappears. Here, I would take my power and multiply it down. So it'd be negative 6t squared, because 3 minus 1 is 2. And the constant disappears. So this would be my velocity equation right there. Now again, graphically, you could see this. So if I just wanted to clear all these out, is we could say that s of t equaled 6t minus, was it 2t cubed, I think? Oh yeah, 2t cubed plus 4. And so our velocity vector is going to show you the velocity at any one point, which is 6 minus t squared. 6 minus 6t squared, if I wrote that right. Okay, so that means at any one point in time, if you want to know what's your velocity at any one point in time here, where it has a x, but it's actually calculating t here. At any time, if you want to know what's the velocity, let's just say what's the velocity at 1. Well, what you could do is if you looked at this table, this would tell you what the velocity would be. So at 1 second, if t is 1, though the position might be 8, it might have a height of 8 at 1, the velocity at that point is actually 0. So notice that that's where we're changing position. That's where the velocity is 0. The tangent line is that flat line going across, and so that's why it graphs it as a 0. That's how you put it together as a graph. So with that, I'm going to let you check out this problem. Try to find your derivative so that you solve for the instantaneous velocity. Pause the video if you need more time. Example 5, the extreme value theorem. It says this: if a function f is continuous on a closed interval, meaning x values between a and b, that f must have a maximum and a minimum value between those values. Now, here's one thing that's wrong with this picture is when you check this, we're going to look for what's called a critical point in a second. And these points right here would be called critical points. Anywhere the graph changes is a critical point, and it's going to happen when the derivative equals 0. Critical point. So you have a critical point. I should say this, a critical point occurs when the derivative of the equation, so I'll say when the derivative, or f prime, it equals 0. So anytime you equal 0, you have a critical point, and we will also test on the bounds a and b. On this problem, or this picture, what's actually wrong is this point right there would be considered the minimum. That is the minimum. Though this is a local minimum, that is a local minimum. The actual minimum of the graph would be this point right there, or you could say a relative minimum. This would be the absolute minimum between a and b. This would be the highest point. That's higher than that point. That is the highest between the bounds of a and b, the highest in the interval. But that is not the lowest. The lowest would be that point right there. So let me put it as a black dot so you can see that this black dot is lower than this black dot. So that would be considered the minimum. This you wouldn't consider because it's outside of the boundary a and b. Okay, so here it says we have a trampoline. The height in feet of a person jumping off a trampoline can be defined by h of t here on the interval 0 to 3. So here's our graph. This is 1 second. This would be 2 seconds. This would be 3 seconds right there. And we want to know the maximum and minimum heights. Now, looking at the picture, we can establish really quickly, this is the maximum. Between times 0 to 3, that's the maximum, that's the minimum. Now, how would you find this if you were using algebra? So I showed you graphically. Well, what you would do is you would take first you'd solve for the derivative. So when I take the derivative, that's a constant, it disappears. This has a power of 1, so 1 multiplies with 5. So you have 5. T becomes the 0 power, so it's gone. So we just have 5 minus the 2 multiplies with this 2, so 2 times 2 is 4, and T drops in power from a 2 to a 1. So there's my equation. So to find the critical points, what I'll do is I'll say 0 equals, this is for the critical point. This one only has 1. So I shouldn't say point since there's only going to be 1. The reason I know it's only 1 is because we only have 1 power here. Equals 5 minus 4t. And so when I solve this, I subtract 5. And I have negative 5 equals negative 4t. And when I divide by negative 4, we'll find out that these negatives will simplify with one another, that t equals 5/4. That is a critical point, 5/4. And so now when you test for minimum and maximums, you need to plug in these values as well as the boundaries, which in this case, this would be boundary A, we'll call this A, and this one's B from the model of that picture. You need to plug in the points. Now we plug in A, B, and the critical points, which in this case, again, is only 1. So let's first plug in the A. When I plug in the A, what I have is in my original equation, A is, plug in A, we don't know what A is. A is 0, let me plug that, okay. So now when I plug this into the equation, H, we want to find the maximum minimum height, so I'm plugging it into the original function h. So I'd have h of 0 will equal 4 plus 5 times 0 to the first minus 2 times 0 squared. Multiplying by 0 is always going to be 0, so that's 0, that's 0. We have a height of 4. Notice this height is at 4 at 0 seconds. Okay, now I would plug in the b value, which b is 3. So let's plug that in. H of 3 is going to equal, and this would probably be quicker if I just use the calculator, but I'll write it out. 4 plus 5 times 3 minus 2 times 3 squared. Okay, PEMDAS says I need to do this parenthesis first. 3 squared is 9. Multiply that times 2. That's going to be 18. Let's go over here. We have a 15 plus a 4 is 19 minus that 18. I'm getting 1. And so at 3 seconds, I should just have a height of 1. Yep, that looks good. And now we plug in the critical point. So I'll just do CP, critical point, which we said was 5/4. So I want to plug in 5/4. And what do we get? We get 4 plus 5 times 5/4 minus 2 times 5/4 squared. So when I do this math, let's see, those 4 plus, that's going to be 25/4 minus, that's going to be 25 over 16. 2 will cancel with that. It'll be 25 over 8. And so when I get a common denominator here, it looks like everything will go into the denominator 8. This will be, when I multiply it by 8 here, I'll have 32 over 8 plus 50 over 8 minus 25 over 8. Basically, it's going to be 32 plus, that's going to become 25 over 8, which I'm getting that to be 57 over 8. Okay, 57 over 8 happens to be a little bit more than 7. So that's a little bit more than 7 there. Let's just write this over here. And now I'm going to show you why I said it would be quicker if I would use this calculator here. H of t equals 4 plus 5t minus 2t squared. And let me get the table. We want the value 0, we want the value 3, and we want the value 5/4. I don't need those. That value right there is 57 over 8. 7.125. Okay, when you look at these three numbers, you can see that this one is the minimum. This one is the maximum. And so that's what we were tasked to find, the minimum and the maximum. Whereas the third value is just a value that's in the middle somewhere. It's not the extreme value. These are the extreme values. And that's what the extreme value theorem said, is there will be a maximum and a minimum. So there's the algebra of how the calculator would solve that. Now I have one for you to try. Pause the video if you need more time. Here's your A, here's your B. You're only looking in this interval. Again, you could graph this like looking in here. We could have said these are those critical values. I got that by going to table and typing in, that's my A, that was my B, and this was my critical point of 5/4 that we found. For you, again, what you would need to do is take the derivative, set it equal to 0 to find your critical point. All right, this lesson ends with a product rule and a quotient rule. What about when we're taking the derivative of a product? If I don't want to distribute out this product, what can I do? Well, you can take the derivative of the function f times g and then add f times the derivative of g. So if you don't want to distribute, so instead of distributing here, you could take the derivative by saying, all right, let's call this portion f. Let's call this portion f. And you could distribute if you wanted to. And we'll call this portion of function h, we'll call this one g of x. What I could do is say that h prime of x will equal the derivative of f times g plus the f times the derivative of g. Just like that. So that's our formula there. So if I wanted to write that out or use that, let's see what we get. The derivative of f here would be 2x minus 2. The constant disappears, so it'd be 2x minus 2. And then I would multiply this times x cubed minus 4 plus, and now I'll take the derivative, or I'll leave f as it is, x squared minus 2x plus 3. And I would multiply it times the derivative of g. 3 would drop down, so it'd be 3x, lose a power, 3x squared. The 4 disappears. Now we can distribute this. So here I would have 2x to the 4th power minus 8x minus 2x cubed plus an 8. Over here, we'll distribute and we'll have plus 3x to the 4th power. Whoops. Now this one here will have minus 6x to the 3rd power. And finally, plus 9x squared. When I combine my like terms, we'll find out that h prime equals, I have a power 4 there. That means we have a 5 4th powers of x's. Going to 3rd powers here, I have a negative 2x cubed and a negative 6x cubed. That makes me have negative 8x cubes. For squared terms, I only have this last one there, 9x squared. I have a minus 8x and then a plus 8. That would be my derivative there with respect to x. Okay, so could I have distributed and still got the same answer? Let's check that and see. So I could have written h of x as being equal to, if we distribute this, I could have said this was 8x squared times x cubed is x to the 5th. So x to the 5th minus 4x squared. And now I distribute this portion, minus 2x to the 4th plus 8x, and then positive 3x cubed minus 12. And that was by distribution. This here is by distribution, so how I got that? That's supposed to be an I distribution. There we go. By distribution. All right, now if we took the derivative of this, I would have 5x to the 4th minus 8x minus 8x cubed plus 8 plus 9x squared. The 12 would go away, and if I reordered this in terms greatest power to lowest power, I'd have 5x to the 4th minus 8x cubed plus 9x squared minus 8x plus 8, which is just as we had before. So you can see that you can solve it either way. You can use, that's called chain rule, or you could distribute and use the normal power rules that we've learned. Okay, so let's see another one here. This time I'm only going to use the one. We will call this right here the one, meaning I'm going to only use the chain rule here. That's f of x. We'll call this g of x. And so if I want to find h prime, I'm going to take the derivative of f, which would be 4x to the 3rd power. 4 comes out front, drop a power, minus here 2x to the 1st power. The 2 disappears. That would multiply times g of x unchanged, x cubed minus x plus 1. And then we would add the derivative of g times f. So I'm going to first write an f here unchanged. X to the 4th minus x squared plus 2. And this would multiply times the derivative of g, which the derivative of g would be 3x squared minus 1. That becomes just a 1. The constant there disappears. So now once I distribute this, I'll be done. So I have 4x cubed times x cubed is x to the 6th power. When you multiply power to power, or when you multiply variables add together like that. So 4x cubed times a negative x is negative 4x to the 4th power. And then I would also have 4x cubed Here I have a negative 2x to the fourth. A negative times a negative is a positive 2x squared. And then a minus 2x. Second term over here, or second factor, I should say. X fourth times 3x squared is going to be 3x to the sixth power minus x to the fourth. Here we would have minus 3x to the fourth power. And negative x times negative 1 is a positive x squared. Last set here, 2 times 3x squared is 6x squared. And then 2 times a negative 1 is negative 2. When I simplify all of this, and I will write in standard form here, I see I have a power to the sixth, to the sixth. I don't see any other sixths. So it looks like I'll have 7x to the sixth power. This is h prime now we're finding. Let's go, I don't have fifth power, but I do have the fourth power here. Here, that's negative 6, negative 7, negative 10. Negative 10, x to the fourth power. Now let's go to the thirds. Third. That's all I have, so I don't need to underline that. Plus 4x to the third. I do have some squareds. I have a positive 2x squared here. There's another one that makes 3x squareds. Add that one in, we have 9x squareds. Minus 2x and a minus 2. And I believe that's all my terms. So that would be my derivative. Quite a derivative there. All right, now that I've shown you two, I'm going to allow you some time to find the derivative of h of x shown here. Pause the video. I'm sure you'll need more time. All right, now we have one more rule to look at today with derivatives, and that's the quotient rule. And this is whenever you're taking a derivative of, say, like a rational function. Here it's represented as f of x divided by g of x, which is fine. Or you could just say it's one function that has a numerator and a denominator. But here will be the rule. You'll take the derivative of the numerator and multiply it times the denominator in its original form, and then you'll subtract the numerator in its original form times the derivative of the denominator, shown here, g prime. And that will all be over the denominator squared in its original form. Okay, so let's try this out. Here again, they call this h of x. We're going to represent h of x as being f of x here divided by g of x here in the denominator. Okay, so for f, if you looked at f prime or the derivative of f, what we would have is the 3 here in the power would come multiply with the 4, and so 4 times 3 would be 12. X to the power of, and 3 minus 1 is 2, so it'd be the power of 2. So that's f prime. And now let's find g prime. G prime will equal, we take the 2 here, the power, and multiply in the front. And right now we only have 1x squared. So the coefficient 1 would multiply with 2. So we have 2x, and the power of 2 minus 1 is 1. So you don't even have to put the 1. The constant disappears. So here's my derivative. Now, in a moment, we will need g squared. So g of x squared, if I use these brackets, what that will be is x squared minus 2 squared, which we could FOIL that out and say that, and then we will put together what the derivative will end up being. Will be x squared minus 2 times x squared minus 2. And if you FOILed all that out, I'm getting x squared times x squared, which is x to the fourth, and then minus 2x squared, another minus 2x squared, and then minus 2 times minus 2 is a positive 4. We could simplify that and say, okay, all of that will be x to the fourth minus 4x squared plus 4. That right there is g of x quantity squared, or the function g squared is what that is right there. Okay, with that, let's find h prime. So if we want to know h prime, what the formula said is you take the derivative of f, which is the 12x squared, and we're going to multiply that with the original function g, which is the denominator up there, x squared minus 2. And then you subtract the original function of f, which is 4x cubed, times the derivative of g, which is g prime here, 2x. All that will be over the denominator squared, which we said was going to be x to the fourth minus 4x squared plus 4.
Time for skyline intake. It is now 8:30. Time for skyline intake.
Okay, now let's distribute here. We will have 12x squared times x squared is 12x to the fourth minus 24x squared when I distribute the 12x squared times the negative 2. And now I have, this is just going to be one simple multiplication. It'll be negative 8x to the fourth. Again, all of this is over x to the fourth minus 4x squared plus 4. Okay, and now I can see I have common terms here. So if I wanted to combine my like terms, 12x to the fourth minus 8x to the fourth will be 4x to the fourth, 4x to the fourth minus 24x squared. All this is over x to the fourth minus 4x squared plus 4. And you could factor out, you could do a GCF up in the numerator just to kind of simplify, to try to factor. So, I mean, this here would be factored form for the denominator. You can look to see if anything will cancel. So I'll start with the numerator here. I see that 4 is common all the way across the numerator, as well as that x squared. So I'll factor out 4x squared. If I do that, 4x to the fourth divided by 4x squared, it leaves me with just x squared remaining. And then over here, when you divide by 4x squared, we're left with a minus 6. Now, unfortunately, that does not cancel. Even if I rewrote the denominator in this form, you'll see that the factors do not cancel with one another. I will leave it here in this form so you can see it both standard form and factored form. So this would be h prime here in factored form, and this right here would be h prime in standard form. So it depends on which form you want it in, how you would write your answer, but there I gave it to you in two separate forms so you could see it as factored form. I'll write that out, factored form, factored form. And this up here is what we call standard form. Where a standard form is where everything has been fully multiplied and your powers decrease in power as you go left to right. Okay, let's try part B. Let's try this again. And so now I'm going to look at this function, and for short, I want you to know that you could just call this f. You don't have to write f of x all the time. You could just write f and g and call this function together h. So I'll write it that way. So let's talk about f prime. F prime here. If I took the derivative with respect to x, the 3 would multiply the x, and this would become a squared because the 3 minus 1 is 2. And then for g prime, the 2 becomes a coefficient, 2x to the first power. This constant also disappears with the derivative, so that's gone. And so finally, let's find out g of x, the function squared, and which means I would take x squared plus 1 and I would square that. And if I FOIL that out, see x squared plus 1. I'm going to go a little bit faster with my algebra this time. I'll let you, if you need to pause it and try this yourself, fully distributing that or foiling out. But what we'll have is x to the fourth. This will be x squared and another x squared. So we'll have 2x squareds, 2x squareds, and then 1 times 1 is 1. And so that's how that will distribute all the way through if you want to find that. Okay, so now that I have these values, we're going to use the to find the derivative of h here, since it's a rational function or a function that can be represented by f divided by g. We are going to use the quotient rule, which states that h prime will equal f prime 3x squared times the denominator, x squared plus 1, minus f x to the third minus 4 times g prime, which is 2x. I guess I don't need to put that in parentheses since it's just a single term. And all this will be divided by g squared, x to the fourth plus 2x squared plus 1. Okay, so let's distribute out the numerator. See what we come up with when I distribute those values here. We will have 3x to the fourth power plus 3x squared. And now I need to distribute the negative here through. Be very careful. So I'm going to actually kind of treat this as a negative x cubed. No, you know what? I'm going to do it like this. What I'm going to do is I'm going to take this away. Here's what I'm going to do. I'll just distribute this portion. And I'm going to write this in a new bracket here. So we have x cubed times 2x, which would be 2x to the fourth. And I put the minus right there. And now I will have negative 4 times 2x, which is negative 8x. And so now, as I try to combine my like terms, it will need to remember to distribute this negative through. And so here comes the standard form. I can see I'll have 3x to the fourth minus 2x to the fourth, which will leave me with 1x to the fourth. And so again, let me change colors here so you can see I need to distribute the negative there and here. Okay, so to keep track of everything. So we'll have 1x to the fourth because I have 3x to the fourths minus 2x to the fourths, which is 1x to the fourth. And then I'll have a 3x, positive 3x squared. And then a negative of a negative is a positive 8x. All of this is divided by x to the fourth plus, whoops, forgot the 2x squared plus 1. This would be the standard form of h prime. And if you wanted factored form, oops, come on, new color. If you wanted factor form, in the numerator, we can look across and see that x, we have a factor of x all the way through, so I could factor out that x, and we're left with x cubed plus 3x plus 8. All of this would be divided, and the denominator we know comes from this factor of x squared plus 1 quantity squared. And so that would be the factored form. You could write your answer in either way. So you could write it whichever way you want. Leave it like that. Again, standard form, factored form. So this right there is the standard form. I'll just say standard form. And then here we'll call that factored form. Now that you've seen me do this twice, I'm going to let you try one. Pause the video if you need more time here. I want you to find the derivative of h given this equation here. Pause the video if you need more time.